participants, and thank you very much for your participation in this 5 days STTP. We are here in the last and final stage of this 1 week GUJCOST sponsored online short-term training program on domains of academia, research, and teaching learning. Here in this last phase, we have organized one more keynote speech for you, which is a kind of what you can do after your PhD or while pursuing your PhD degree. So here, while getting that keynote speech, the topic, we have with us right now Dr. Amit Sata, who is Associate Dean, Innovation and Entrepreneurships at Marwari University. So we found him somewhat more useful to discuss with all these funding opportunities or how to carry forward your research. About Sir. Sir is here, professor in the Department of Mechanical Engineering, Faculty of Technology, Marwari University. Sir is having more than 15 plus years of experience in terms of engineering, entrepreneurships, teaching, and mentoring. Sir has earned his degree of PhD from IIT Bombay. So I would like to invite now Professor Dr. Amit Sata sir to deliver his keynote speech on the occasion of this valedictory function.
Yeah, thank you. Thank you very much, sir. So good afternoon, everyone. This is Dr. Amit Sata, working as a professor in Department of Mechanical Engineering, Marwari University, and additionally, I'm also heading the Innovation and Entrepreneurship Cell at Marwari University. So basically, I'm a kind of mechanical engineer and mainly dealing into the one of the domain into the mechanical engineering called mechanical engineering. In that there are various domains, but I belong to the manufacturing domain. But today I will not talk about the too much scientific or technical fundamentals. My talk, or I would not say it is a kind of expert talk or something. It is just a journey what we have followed so far at a university, specifically the journey what we followed as a team into the university, specifically in the Department of Mechanical Engineering and into the domain of manufacturing. So basically I will talk about something about the collaborative and translational R&D, research and development. And many of you already hear so many eminent personalities during last few days. So I will also not talk about Hello.
Oh, sir, please continue. Please continue.
Yeah. Sorry. So I will not talk about how to conduct research and how to, or I will not teach you, or I will not give you any guidance related, because all of you are very much domain experts. So I will just share our journey, how we did certain collaborative R&D and how we take it to the next level. So as this talk, or as this entire STTP is mainly focused onto the research methodology and all these things. So most of the times as an academician, we started to pursue the research from some idea, right? We were having a certain idea, that idea we are taking forward and conduct so much amount of research. And as an academician, we always ended as an outcome of the research to either say publication or filing the patents and all, right? So obviously it is not a bad thing to do it, right? But then what is the next level after that, right? It means idea ended, or idea has been transformed into the research. Research is actually ended into the publication and patent. But now what next? Can we earn profit out of our idea, or can we earn profit out of our research? That's what I will try to talk. And in that, actually, you alone cannot do any work. As far as my philosophy is concerned, it is a collaborative world right now. Either you acquire the certain amount of the skills, or you connect with the people, those who are having a different kind of skills. So today we'll mainly talk about the collaborative and translational R&D. So it is nothing but the R&D, but what you need to do into the conducting the research and what next after the research. That's what we'll try to do. And most of the times, whenever actually I start my talk, right, that will be starting with saluting the two inspiration, two gurus, to whom actually I followed in my life throughout my entire career. I admire these two personalities a lot. I learned a lot through this personality. The personality onto the left hand side of your screen is Dr. John Campbell, one of the most eminent professor, renowned professor, faculty, academician, researcher into the domain of manufacturing and into the mechanical engineering or manufacturing. If you will tell who is John Campbell, then everyone really appreciate his efforts into the domain of metal casting. And his entire life is actually focused on conducting the research into the one of the most oldest or one of the oldest manufacturing process called metal casting. So left hand side of your screen, who is pioneered eminent personality in the domain of research. Onto the right hand side, who is supposed to be a Dr. B. Ravi, Institute Chair Professor in Mechanical Engineering Department, IIT Bombay. I did my post-graduation and PhD under his supervision. He is also mainly one of the well-known eminent personality in the domain of not only in manufacturing, in our domain, metal casting, but also in biomedical. So he taught me how to translate the research, right? So onto the left-hand side, I admire that personality in the domain of research. And onto the right-hand side, by whom actually I inspired to translate the research, right? Translate the research to the industry, to the any level of entrepreneurship and all. So they have, both of them are having a or I would say large number of publication on their name. So many patents they have filed, and more importantly, so many ideas they have transformed into the innovation to the next level, and they are also mentoring so many startups and entrepreneurs in that domain, right? So these two personality actually I admire a lot. So usually I always started the talk with my inspiration. So as both of these gentlemen belong to the metal casting, so just I will give you, those who are not actually into the domain of metal casting, just very common, not in a mechanical engineering language, but in a common man's language. If I would say metal casting, which is one of the most oldest or one of the oldest manufacturing process in the domain of engineering, and its root has been found out way back 5,000 years ago, where actually earlier it was used in making the idols, jewelry. Most of us, we have seen the jewelry, right? Many of us, and idols, what we used to see into the temples or any kind of castle or palace, or all these were produced by the process called metal casting. But nowadays, actually, this process is used into the so many applications into the different sectors, including automobile, aerospace, defense, biomedical, chemical, and so on. Application is never ending, right? But basically, the process is all about you are having a molten metal, you are going to pour it into the certain cavity. After the solidification, you are having a product called casting. But we'll not go into the detail. Directly, we'll jump into the most advanced technology for conducting the R&D in this era. Everyone has heard about this terminology called Industry 4.0, Internet of Things, Industrial Internet of Things, Smart Factory, Smart Manufacturing, and so on. So onto the one side, we are having one of the most or one of the oldest manufacturing process, which is called metal casting. Onto the other side, we are having one of the most advanced technology into the domain of R&D. So two extreme ends of the technology, 5,000 years ago or old technology and the current technology. So in that direction, we were thinking that how to combine these two technologies together. And that was the idea, actually, what I always believe that any research or anything, it simply starting with the idea, right? So that idea click into our mind. It was not in that, but into the other domains also across the world. This is the main technology what we are hearing so many times, and even into the last 2 years, I believe that more than 2,000 webinars have been conducted in that direction. Industry 4.0, smart manufacturing, manufacturing innovation, industrial intelligence, so on. So people are referring this philosophy by a different name or a different title across the world. But the concept is that you need to apply, you need to go with the different industrial revolution while you are dealing into the engineering domain. So that was the idea behind it. And that idea was not actually clicked a year ago or just a month ago. It was clicked in the year of 2015. So that idea was clicked into the year of 2015, where we were thinking that why don't we combine the two extreme end of the technologies, metal casting with the industry 4.0. And that was the idea was not clicked only in my mind, but it was clicked among the 10 passionate people across India, those who are specifically working into the domain of metal casting. So at that time, we all people came to one platform due to the kind effort of the personality what I have shown into the second slide, right? Dr. B. Ravi, who was supposed to be the mentor. And all these people came into the one roof, under the one roof, and think of that ki why or how we can actually bridge the two extreme end of the technologies and come up with the excellent idea, what we called as a Smart Foundry 2020. So at that time, just I'm sharing the one photograph, what we have clicked in the year of 2015, latter part of the 2015, where all we gathered and had a strong discussion that can we develop a smart foundry for our country. So all this is representing the different domains. If I will just share the few glimpses of them, some of them are the director of the research lab of India, like the Dr. Naga, right? You can see that Dr. Naga is the director of the CMTI. Few of them are director of the NIT Manipur, the professor from IIT, not only into the domain of mechanical engineering, but the people from metallurgy, mechanical, mathematics, computer science, all came into the one platform and started to think that why don't we prepare the industrial 4.0 version for our country in the year of 2015. So that was the idea. And then we gather all our expertise, competency, and we thought that how to complement each other. And we have written a one proposal to the Department of Science and Technology, Government of India, in the year of 2015, that why don't we develop a smart foundry in India? So we all came together and the proposal was written in the amount of somewhat slightly above the 9 crores. And we all have came into the one platform and applied for that proposal. I'm happy to share that the government of India appreciated our idea and accepted our proposal. And that was the kind of very unique project in the year of 2015, where actually all the stakeholders or all the researchers are coming from the different institute, not only institute, but it is a combination of R&D institute, what you can say IITs, NITs, R&D labs, and the private institute like us. So we represented the more than 10 institutes. So it becomes an excellent collaborative R&D project at that time, and which was one of the highest funded project in the year of 2015, the project called Smart Foundry. So we actually people from, as I told you, different parts of India came together. So I was fortunate enough to be part of that project in the year of 2015, where more than 10 institutes plus 5 other industry have collaborated with us. So it was becoming a multi-institutional, multidiscipline kind of R&D project, right? So that was appreciated at that time, and we started to work an individual into the each institute and trying to combine all these things, put it into the one project. So that was actually a team, what we are having, or say collaborative team at the national level. The same team actually was distributed at the university level, which is also a combination of different type of people all together. So one collaborative efforts which was going on at the national level, and another collaborative effort which came at the university level. So we are having a few JRFs for this project, few postgraduate students, few PhD students, and many more, I would say, undergraduate students belong to the different domain like mechanical engineering, electrical, computer, ICT. So all actually came together to fulfill the overall objective of the smart foundry. The overall objective of this project, actually I will not go into the complete technical aspect into the project, looking towards the diversified crowd what we are having in this. But the overall objective of the project is to achieve the real-time monitoring, or I would say process monitoring onto the any process followed by the data analytics. So overall concept is to transform the typical manufacturing industry into the India, which is belong to the second generation of industry, and take them to the fourth generation of the industry. So that's what we started to do. And after putting all the efforts of the different students all together, faculties and all, finally we have combined. Actually, I need to. Yeah. So I think the video is clearly visible, right, to the everyone. So that's what we did. We developed one simple prototype at our university, which will be developed by the mechanical engineering students. All the hardware which is in front of you is developed by the mechanical engineering student, which is also having a provision of melting furnace, which is developed by our electrical engineering students. We place the various sensors into the machine. So it was done by our ICT students, and the application which is in front of you is developed by our computer engineering students. So whatever the information we are having in that machine, we are able to streaming to the Android application as well as the dashboard. And you can also operate the entire machine, as you will be able to see that we are able to rotate the one segment of the equipment through Android application. And that was developed in the year of 2017-18. So basically, as far as the research project is considered, we have achieved a good result as far as this result is concerned, right? And the DST, the Department of Science and Technology, has also appreciated what we achieved in the year of 2017-18. At that time, it was a kind of difficult task, I would say, but due to the excellent effort of the team of the students, faculties, and the support what we got from our team management, we are able to achieve. So as far as this is concerned, the collaborative R&D achieved a very good success. And we could have been happily slipped onto the night with having a good dreams and all. But then actually we started to think on that, irrespective of the research what we are conducting, and then lying onto the, say, what you can say, into our laboratory, academic lab, all will appreciate. And I'm not saying that we have not achieved in terms of publication. We have filed, or we are having a more than 12 publication for this R&D project. We have filed nearly 10 patents out of this project, and we got the, I would say, 6 or 7 copyright for the software, what we did out of this. So it was a remarkable, considered to be a good R&D achievement in this. But then actually thought came in our mind that whatever we are doing is good for the academic level, but if the country will not be benefited out of it, then it is actually kind of useless, right? So that give us the concept of, say, translation R&D, which was not so new concept, but just I would like to, what you can say, just explore that more and more. So basically, it was, as I told you, it was started with the idea among the minds of passionate people that why don't we develop the concept of smart foundry in that. And then actually we started to conduct the research out of it by actually, I would say, crossing the relatively small, deeper valley, right? So we transform idea into the research, and then actually we come up with, I would say, entire flows of research we transform into the product, just to be actually passed through the relative deeper valley, right? And most of our emission into the search into time are talking to the search, say, publication to the paper, patent, or whatsoever. But as an academician, as a researcher, also cross this valley and try to translate the research into the product. Then actually the largest valley will come in front of us, which is called product to profit. So in that, actually idea need to be translated into the research, and then real work starts. We need to transform the research into the product, translate the research into product, and that product should yield into the certain kind of profit. Then actually what we call IRPP philosophy will be work. So, but throughout this journey, actually, throughout this journey, we need to cross the ideation valley, we need to cross the research valley, and one of the most important part called death valley, where actually the many of the products are not transformed into the profit, or many of the research has not been translated into the profit. Now for that, actually, as an advice point of view, as a guidance point of view, it looks very easy, right? And somebody will also appreciate that point. So actually it is always easy to advise than the doing it. So I'm not going into that part, but what I'm trying to say that we followed that journey. So the concept, what we started with the idea to create the bridge between the two extreme end of the technology, we conducted the certain research out of it, and then finally we transformed them into the one of the startup. So in the year of 2019, actually, we thought that whatever the research we have conducted, why don't we start our own thing? So as a university, I discussed that idea with our authorities, and authorities have happily accepted that. So basically, this startup is actually incubated by our own incubation center, and we started to apply what we learned through ideation or say research into the real industry. And into the 2019, one of the industry in Rajkot accepted our own research, our own concept, and provided us to have a excellent platform to translate our research into the product and allow us to transform their own industry into the smart industry. So that was the overall thing what we started in the 2019. Then actually it goes like that. So currently we have transformed their entire industry, which is located in Rajkot. We transform them into the smart foundry. What we learned into the say research project, we translated actual work. So whatever the things we have incorporated, it has been showcased in front of you. I hope the video is clearly visible. So their entire industry we have transformed into the 12 sections, starting from customer section to the purchase or dispatch section. So once you will go that into any one of the section, what we did actually, we have not asked the industry to replace their existing equipment for transformation into the smart foundry. we studied their own equipment and we develop a certain solution for them so that existing machine can be transformed into the smart machine at very affordable cost. So for example, this is the application in front of you, what we did for that industry, right? So basically it is becoming the concept of say executing the concept of say, what you can say, translation R&D. So this equipment, we transform them, not only this, but there are series of such equipment which we have transformed into the uh, uh, smart equipment so that all the data can be streamed onto our platform, not only dashboard, but onto the right hand side, you will be able to see that similar can be available at your smart device. Right? So that's what we did as a part of this project, and we successfully actually completing that project with the one industry, and now with the other industry we already started. So this is the overall thing what we did for the industry, right? So in general, what we learned through the ideation and research, we started to transform the existing manufacturing companies into the smart manufacturing companies through various products, various modules, including process monitoring, data management, some of the measurement devices, and data analytics. So in general, actually, we are reinventing the manufacturing process and transform the classical manufacturing into the smart manufacturing company. So now whatever we did, actually, as I told you, we started with the one research project, which was actually in the year of 2016, where the government has funded us. Then we translated that research into the form of the startup, which was actually initiated in the year of 2019. And I'm happy to share that this idea of the startup or say translation R&D was also appreciated by the government of Gujarat and awarded us the 20 lakh rupees as a part of the industrial commissionerate scheme. So during the visit of former chief minister at our university, he appreciated our idea of the translation R&D. So without actually taking too much of time, I would like to pause here, right? So this is the journey what we are having, and irrespective of the research into the different domains what we are doing, I would urge all the researcher that to think on to the concept of translational R&D. Don't stop by at the point the research can be transformed into the publication or patent. Please carry forward the research into the next level of say product for a particular industry or a particular irrespective of your domain, and then further translate that product into the profit. Then actually the entire journey will become more and more useful for not only for us, but students point of view, academics point of view, or industrial point of view. I would request to have a more and more collaborative and translation R&D. By this, actually, I thank all of you for having patience listening. So keep in touch, right? Any kind of things where actually we can collaborate, we can think of having any joint projects or anything. Or you are, if this session is although offline, right, say online mode, but whenever you are having a time to visit our university, right, I request all of you to visit our innovation and incubation center, where actually many more this kind of startups are working, right? So thank you, all of you. Yeah, over to you, Talkar sir. Thank you.
Thank you very much, sir, for your remarks.
I've not taken too much of time.
Oh, not at all, sir, not at all. Actually, this is very important, how to translate your research and development, get the product and market it. That is what you are doing actually. That is very important. So thank you very much, Professor Amit Sata, sir, who is Associate Dean here at Harvard University.